Starting with a quick sketch. And we know that we're looking at 135. So 135, we get to there. We know this is 90 degrees. So it's bigger than 90 degrees for sure. Not as big as 180 degrees, so lands somewhere in there. So to get the exact reference angle, we can say 135 there. It must be 180 minus 35. So we can just point out our work. 180 minus 135 equals 45 degrees. So reference angle in here, 45 degrees. All right. And so we can draw in our right triangle from there. One thing we do know about 45 degrees is that it's halfway in between. So for every one we move over, we go up one. In this case, we're going left. So we know that the x value is a negative. The y value is positive, so everything's good there. Now, 45 degree angle, we should start remembering this as one of our exact triangles. And so we should be able to soon be able to just write in root 2. As we get ready for that, or as we get better at that, if we ever have to double check it, we can certainly say r squared equals the one side of that triangle plus the other side, and 1 squared is just 1, so we bring that together as a 2, so r would be a root 2. So you can always verify that if you need to. So at this point, we're ready to do some ratios. Sine of, well, I guess we can write it in as sine of 135 is equal to, and sine is opposite over hypotenuse, so the opposite is 1 over root 2, and we can rationalize that denominator. So multiply top and bottom by root 2, and there's our sine. The cosine of 135 would be, again, adjacent over hypotenuse, so negative 1 over root 2, and rationalizing would give us just a negative version of that. Okay. And the last ratio we're looking at is tan of 135. And so the tan of that would be opposite over adjacent. So 1 over negative 1 or negative 1, and we'd be all done.